I'm hoping we can crank out your lab grades really quickly this week, hoping to get something like one done a day. So that you, again, have much more feedback about your standing in the class. But just with how much has been going on, it's been really difficult, especially paired with compilers. That's a very intensive homework course. And those homeworks take a very long time to grade because there's no one right way to do it. It's very open-ended, and if it's very open-ended, I don't like placing restrictions on people to say you have to use exactly this notation, exactly this way to make it easier to grade. I want people to have a little bit of flexibility, but then the issue with that is it is harder to grade.
Oh, yeah, when is the final?
Our final is Friday afternoon, I believe. I can look up the exact time and post that to Canvas, but we're just about the last slot in here, I believe. Does anyone know off the top of their head exactly when it is? Friday, 1 to 3. Friday, 1 to 3. We'll go with that. I will fact check that and post something eventually. And that is next Friday, not this Friday. We still have course meetings through this week and then next Monday. And my plan at the moment is just to have a review session next Monday, as it's the day before finals. So of course, as always, attendance is somewhat optional. I think it would benefit you greatly to attend, be able to ask questions and hear other people's questions, but I will also record it if you are busy preparing for other finals or have other things going on and don't feel like you would contribute a ton to that with your questions. I will post that review session ahead of the Friday final. Other questions before we get started?
Is the final going to be cumulative?
It will mostly tackle the material since the last exam, but there will be a cumulative component to it, but it's at a high level. So rather than asking you small questions about design patterns, they will be larger scope questions about selecting the appropriate design pattern or something like that.
And we're getting a study guide, right?
Yes, I will have a study guide for you at least a week in advance. I'm currently prioritizing compilers because their final is Tuesday at 8 a.m. So I want to give them the full week. 8 a.m.
Oh, I hate that.
And then I also know that Harley did reach out with an announcement about coming and seeing him with any concerns about grading if he wasn't able to compile your work, because we've been dealing with so many different versions of Java and versions of JUnit, and some of the JUnit from the labs are a bit outdated. I think some people have understandably had some issues on Harley's system getting that set up. So I don't know. I don't think he's planning to reach out. I would think that either you would be unsatisfied with your grade, saying that it should be higher than it is, or preferably he should be leaving some kind of feedback that says, come see me, or something of the sort. So I'll make sure that he's doing that. And otherwise, if you are unhappy with your grade or feel like it is unfair, please do talk to him. I'm sure that he'll be able to justify why he did what he did, or be able to make the associated change if you can explain what happened and help him to be able to run it and test it.
So if we get feedback on the labs like this week, and we want to like work on them, could we resubmit them?
I don't think we're gonna have time to do additional grading. What I can say is that I will be curbing the whole class because of it. And I know that has been an issue for the entire course. And I'm pretty sure that everybody would want to do some work and resubmit based on that feedback. So I will do an extra curve on the final class grades rather than overburden my TA with grading he's not going to be able to get to. In a perfect world, yes, you'd be able to iterate on it and get feedback on it. But I think that with both his time and my time as crunched as they are, I just don't think it's particularly, I don't think we have enough hours in the day to be able to do this to the extent that we would like to. And that's not particularly cool or fair to you. So the best that I think that I can do is curve those final grades in a way that at least says, I know that you're capable of iterating on feedback. So you'll get some credit for that. Still not happy with it though. Myself personally, I would
Just like-
prefer that you have that feedback with the ability to iterate on it. Does anyone want to invent more hours in the day? Just make that happen.
You just work more hours.
I mean, we just lost one yesterday.
We did, right? How'd that happen? We can just put, jet engines, very, very, very large engines on the planet Earth and just like push it out from the sun a little bit. That way the day we can slow the rotation a little bit, the day will be a little bit longer, the year will be a little bit longer. Slow down the rotation a little bit.
Don't know
Here's
how that
what
would
the-
affect the water, but
I
small price to pay, small price.
I was
I go
up
back
at 2 AM and I thought, I'll get 7 hours of sleep, that's fine. And I hit 2 and then went to 3. Oh,
Oh,
no.
no. Stupid daylight savings time. When is this gonna end?
I only like daylight savings time when it gives me an extra hour.
Yeah.
I don't like losing it.
Yeah. Especially since it's right at the end of a quarter too, it's just like, give all the projects due, exam prep. All right, well, we should get started with these couple design patterns. The plan for the week is, so you're not gonna be getting any labs on these patterns. I will be testing you on them kind of at a higher level, but I won't quite go into the same level of code depth that I would require for the patterns that you've had examples of. There will be an observer lab that we will do this week. So I will try to assign that tonight, have that due next Monday, basically as late as possible. But I think observer is a good one to get experience with because it's a very important pattern and it's very distinct from the other patterns. As is adapter and facade. So this will be, they're fairly similar to each other, but they're very useful patterns. Ready to go? Any other questions? All right. So adapter is going to be a little bit like decorator, just a little bit. So I'll set the scene with something that we've seen before. With our decorator, we wrapped objects, we gave them additional functionality through that wrapping or new responsibilities through that wrapping. We were able to add some additional fields or methods to an existing object to give them that added functionality. We can think now about, imagine that we have a design and our code is expecting to belong to a particular interface. But the code that we want to work with expects a different interface. So we have two different interfaces. We have the expected interface from some code that we want to interface with, and we have the interface from our design. This happens very frequently, especially if you're dealing with legacy systems. Legacy systems have particular interfaces for older versions of a programming language. And to change that interface, you'd have to go completely change that code base. And it may not be a code base that you even have access to. It could just be that you need to interface with someone else's system and you've implemented a design that does not adhere to that system. What can we do about that? So this design pattern helps you wrap an object in some additional logic that converts between two interfaces. The interface of your design and the interface of the code that you want to work with. You can think of this very much like any kind of cord adapter or plug adapter. You could have like an HDMI to, I don't know, lightning port. Lightning is charged, I don't know. Some kind of, any kind of cord that you have management for, maybe most recent would be like HDMI to DVI, maybe anything else where you're converting one signal to another signal.
USB could take,
Yeah, USB-C for sure.
AV.
Yep. So the example used in the book is going from a US plug to a European plug. You have the adapter, and on one sense, you plug into the adapter, the US power, and then you plug the adapter into the wall, and you have simulated the full system. You have adapted your device to fit the power needs of what the wall expects. So this will just be the code version of that idea. How do we design this adapter so that code plugs into one side and it plugs into the other side so that you can communicate between those two sides. So we're going to go with, you have designed a software system to work with a particular vendor's interface, but then your boss gets mad at you and changes up the vendor someday and says, I found a cheaper vendor, but the vendor uses a different interface. So now you need to design some kind of adapter from the old vendor's interface to the new vendor's interface. So you need to convert the code that you've produced so that it runs on their system. You have two options to do this. You can redesign your entire system from the ground up to work with their interface, or you can write a single adapter that converts your old interface into their new interface. So your existing system has a very different very different way to plug in than the vendor class. So you're putting, in this case, a triangle-shaped object into a circle-shaped hole. That's not going to go particularly well. So you write an adapter class that takes as input the triangle-shaped existing system and converts that triangle-shaped system into a circle-shaped system, and then plugs the converted circle-based system into the vendor's class. So you end up with a system that works. Make sense? It's exactly like any kind of adapter plug, which is why we call it the adapter pattern. So let's think about actually how we would do this in code. And of course, it's been so long since we talked to our old friends, the ducks from the strategy pattern, that we're going to go back to it a little bit. So the problem, and hopefully this gets a couple chuckles. If it walks like a duck and quacks like a duck, then it might be a turkey wrapped with a duck adapter. So we want to add a turkey class to our duck hierarchy from the strategy pattern, but a turkey obviously isn't a duck. A turkey is going to not quack, but gobble. And we need some way to interface with the duck interface, even though we don't have a duck. So we're going to simplify the duck implementation. We're going to strip out all the strategy pattern stuff from it for now, so that we can look at it as simply as possible to show how we could apply the adapter to making a turkey fit into a line of ducks. We're going to hide the turkey in the ducks so that the objects don't know that it's there. It thinks it's a duck. So here is the duck interface. Remember that ducks quack and fly. In the strategy pattern, we had quack behavior and fly behavior as a separate class. We're stripping that out and just including them for the moment as methods within the concrete duck, the mallard duck here. But we also have, and I probably should have done this before zooming in, a turkey interface and a turkey object. So just like we had a mallard duck, we have a wild turkey that implements turkey that gobbles and flies, but doesn't fly quite as far as a duck because, I don't know. Who knows why turkeys don't fly as fast or as easily as ducks?
They're lazy.
Yeah, all right, we'll go with that. They're lazy.
Probably.
If they just try harder, they could fly better.
No, turkey makes you sleepy. Now I want some turkey.
We keep talking about food in here, don't we? So what can we do to make a turkey adapter class that would say, all right, we have this turkey object, but we want it to be able to basically pretend to be a duck. So we could incorporate it with a bunch of mallard ducks. We could actually implement the duck interface on a turkey, but ducks quack and turkeys gobble. What could we do? So first, if we were writing this actual adapter class, which interface should the adapter class implement?
Sure.
I mean, it shouldn't be on a duck, 'cause you're just trying to like modify whatever is in turkey.
Yes,
Duck.
that's exactly right. So we should be implementing the duck interface because we're gonna be taking a turkey object inside of the turkey adapter. The input to this is going to be a turkey object. The work the turkey adapter is going to do is convert that turkey into a duck so that it can work with the duck interface. What fields are there? What is the state of a turkey adapter? What do we need with regards to state? What fields?
I mean, we need the turkey object, right? So
Yes.
we need something to hold that. And then we need to find out what the duck class needs and how to interpret the turkey into the duck fields.
That will be in the methods.
Okay.
So that's a great idea. In fact, there's only the one field, the turkey object, that's gonna be passed in. Basically, this is going to be the super secret spy something. We pass a turkey into this adapter and the curtain falls. And when the curtain rises back up, it's put on a duck costume.
Quack. It's just turkey.com.
Yes, that's exactly what we're gonna do. So what methods do we need for this? Well, we need to teach the turkey how to act like a duck. So we need to convert the turkey's gobble into a duck's quack. So a method will do that. It will simulate, it will basically tell the duck class that we're going to quack, and when we quack, the turkey will gobble. So here's what it looks like. Is that visible? Can zoom in a little bit. Looks like it's a little bit zoomed out. In we go. So we implement the duck interface. In the constructor, we're gonna pass in a turkey. We set the field to be what we pass in. And note that since we're implementing the duck interface, we need methods for everything in the duck interface. So we need a quack method and we need a fly method. But we need to convert what the turkey actually does into what the duck does. So when the duck quacks, the turkey gobbles. And when the duck flies, the turkey needs to fly 5 times. So that's how we're going to implement this conversion logic. So now when I give orders to all of the ducks and say, hey, quack, the turkey in there will gobble. But it's responding to the command to quack, so it's quacking, right? It just stands out a little bit. And then when we say fly, all of the ducks fly once, but the turkey sees the fly and says, all right, I need to fly 5 times to make up for the fact that all ducks are flying once, since I'm lazy. All right, so that's the turkey adapter. If we want to test this out and make sure that this works correctly, we can use a driver program. And here's the test drive. So we're going to make a mallard duck. We're going to make a wild turkey. And then we need a turkey adapter that is of type duck. Notice that again, this is the abstract version of duck. The interface version of duck, because it's not a mallard duck, it's not a particular type of duck, but it should be able to adhere to the duck interface. So we declare the turkey adapter to be of type duck. When we make the turkey adapter, we pass the turkey object. Now we're able to say something like turkey.gobble and turkey.fly. That's just using the turkey's everything. And then we're able to call the test duck that we already wrote. But now we can have the turkey adapter now run the test duck method on the turkey adapter object. And what this does is it does everything the turkey is supposed to do, but calls it like it's a duck. So it's giving orders to a duck, but the turkey is what's doing everything that was commanded of a duck. So it can simulate and do everything that a duck can do because we've talked about and given the logic for what it means to convert from what a turkey can do to what a duck can do. So we have a turkey adapter. And in the test run, note that we've just used the turkey adapter as a duck. So it still gives the output from the turkey, but it's able to now interface with the duck interface. Does it make sense how this relates to something like using a new vendor as an interface? Because you still want it to do the same thing that it used to do, right? We don't want the turkey to actually flying like a duck. It needs to do what a turkey does, which is gobble and fly, but we need to give it the orders of a duck in order for it to do those things. So it's very much like using a new vendor system. You still want your system to do everything that it used to do. You just want it to interface with the names of the methods and the logic that the new vendor system is using. So let's quickly just talk about the adapter pattern as a whole. We're kind of running out of time, but this should be the last slide. Big picture view, we have the client, we have the adapter class, and we have the thing that we need to interface with that might not quite be what we are expecting. So the client sends a request to the adapter implements the target interface, holding an instance of the adaptee, and then does the associated conversion logic, the translated request, and it's able to pass on that request to the adaptee through that conversion process that's defined within the adapter class. So the client makes the request to the adapter, and then the rest is just magic from the client's perspective. The client doesn't actually need to know the rest of what goes on, but the adapter will translate the request into one or more calls to the adaptee. The adaptee returns with the results of that call, and then the client gets it back. And note that the client just made the calls like it was expecting it to. It didn't know that it was communicating with the adaptee. So you can also think of it kind of like Google Translate. You could be having a conversation with someone who doesn't speak English, as long as you have a very good translator in the middle that's capable of one-to-one translating anything you say to something the person on the other side will understand. When they respond, it translates it back. So it seems like you're having a conversation with someone who's speaking English, but you're the only one speaking English. The other person is speaking whatever language is their first language. All right, we will come back to this tomorrow and finish off adapter and facade. I will get the last lab to you and see how quickly we can get some feedback to you on the existing labs. Harley will be around this week from 1 to 2 for you to have any questions, argue any grades with him to make sure that we're all on the same page going into finals week. See you all tomorrow.
Thank you so very much, and you have a very good day.
You too.